Ladies and gentlemen, hello and welcome back once again to the briefing room. My name is Eric Cavanaugh. I will be your moderator for today's event, in which we're going to dig into one of the most interesting concepts I've come across in a while, and it's one of the ways that you can achieve really fast speed for your analytics. So we're going to be learning about that in today's broadcast. So there's a slide about yours truly and enough about me. The mission of the briefing room, I think many of you know, is to reveal the essential characteristics of enterprise technology. So we're really trying to get into the weeds and understand exactly what these technologies are all about, how they work, what they do, and when they are applicable. So we cover a different topic every month. May, of course, is analytics. So we'll be digging into several events this month to understand how these different analytical solutions work. So obviously there are all kinds of analytics, and there are all kinds of ways that you can crunch numbers and figure things out and get things rocking and rolling for your organization and for your insights. But the big question is which ones to use, when, where, how, why, and so on and so forth. It's not the easiest thing to do, so what you have to do is figure out which technologies apply to your particular use case. So that's what we're going to dig into today to better understand how these technologies work. So our analyst is going to be Robin Bloor, and then we're going to first hear from Fred Gallagher of Actian, formerly called Ingress. Actian has some really interesting technology, and it even optimizes for chips, so we're going to learn about that stuff today as well. So there is a slide about Fred. I'm going to hand him the keys right now. And Fred, go ahead and move the slides, and then after that, Robin will talk, and then we'll do the Q&A. So go ahead. Fred?
Yeah, can you hear me?
Yeah, I can hear you now. Okay.
So there we go. So yes, this is Fred Gallagher. Thanks a lot, Eric. Excited to be here. I'm General Manager for the VectorWise business globally at Actian Corporation, and I've been living and breathing VectorWise for 3.5 years, so it's been a great experience, and I'm excited to talk to you about it. So let me just go ahead and move on. So we're going to talk today about this concept that we call conversational analytics, and I'll go over very briefly Actian Corporation. I'll talk about this concept of conversational analytics. We'll dive into some of the technology around VectorWise that enables this. We'll cover a couple proof points, and then I'll talk about a next generation initiative we have, and then we'll wrap it up. So moving on, Actian Corporation, we're a data management company, as we'd said, and we have 3 distinct product initiatives. We have the Ingress database, which has a history of providing mission-critical transactional capabilities to companies for the past 30 years. We have VectorWise, which is what I claim to be the world's fastest analytical database. And we have an initiative called Action Apps, which enables actionable BI. And I'll go over that near the end of the presentation. So let me jump back to VectorWise for a second and start to talk about conversational analytics. And VectorWise, people say it's really an incredible database technology and that it's very fast, and it is, but it's a whole lot more. And really, what we like to talk about is this concept of conversational analytics. And when I think it's a whole lot more than just a fast database, VectorWise is really kind of at the juncture of this new set of technology. We're kind of breaking from the past 30 years and bringing forward a capability that is allowing people to analyze data real time and in the moment. And where we've come up with this term conversational analytics is that a conversation is a good analogy. If you think about a conversation, it needs to be interactive, it needs to be engaging. If it's not engaging, it's boring, and it needs to be meaningful. So those 3 things: interactive, engaging, and meaningful. And if it's not meaningful, it's probably just gossip. And so what we're able to do here is we're really allowing people to engage their data to solve business problems in the moment. And let me kind of move forward with that. And oh boy, hold on. I just jumped 20 slides. Excuse me. All right. We'll fast forward through this part. All
No worries at all.
So when we talk about, so the thing about conversational analytics, you know, from the perspective of you have a problem and you would like to solve that problem in the moment, and you'd like to solve it with data. And you want to do that as opposed to guessing or calling up somebody on your phone who's a good guesser. And so you want to bring data into the moment to make that decision. And when I talk about conversational analytics, again, I talk about this back and forth interactivity with the data, which is on the time that should be human time for a conversation. If you're having a conversation with someone and that person asks you a question, you really, unless you're going to be rude, you should answer that question probably in about 5 seconds, maybe even, you know, for sure less than 10 seconds. If you actually sit there and counted for 15 seconds, you'd find that, you know, you'd think there was something wrong with this person if they weren't asking you or answering your question in a timely manner. And so what does this allow you to do for your company? You know, it's about enabling your employees to solve business problems in the moment. And when you do that, you're helping your customers, and you're making your customers happy, you're making yourself happy, and the only person that's not going to be happy at that point is your competition, because you've beaten them to the punch there. And I think some of the best ways to think about this is to actually provide a bit more context and talk about some examples, and maybe even start with an example that's not conversational analytics in terms of an experience. And one of the segments that we see some good uptake in our business is in the retail area. And so if you've gone to a store, be it a supermarket or I'll go to an electronics store, a computer store, and you get to the counter with my electronics, and the checker always asks me, okay, is it going to be cash or credit? Well, I always pay with a credit card. The next question is, all right, would you like to sign up for our company credit card? And the answer is no. Well, that whole conversation added no value to my life, and frankly, unless I got the credit card, it really didn't help that retailer. They didn't sell me anything extra, and so it was not acting on any data in the moment at all. Put it forward as having that retailer enabling conversational analytics, and I'm going to an electronics store, and I'm buying a DVD player, and I swipe my this time I have a loyalty card, not a credit card, but a loyalty card, so they know something about me, and they understand, hey, Mr. Gallagher, could we make some suggestions about this DVD player that you're about to purchase? Or maybe it's a game console for my kids. And they say, you bought a TV here 2 months ago, and this is not compatible. This DVD player is not compatible with that TV or even some of the DVDs that you purchased. And so we'd actually recommend that you buy this other product that happens to be on sale right now. And it's a little more expensive, but it's still on sale, so you're going to save some money. If you look at that example right there, what's happened is it's added value to me, because I'm not going to go home and with a DVD player that's incompatible, and so it's satisfied my needs. The retailer has sold me something that I like, so customer satisfaction is good for him, and also he's probably made more money in that particular transaction. So that's an example of conversational analytics, and you can come up with other ones in your daily life when you're trying to solve a business problem that's more you'd like to bring data into it and not be going on gut feel or on a hunch. And so this really requires the need for speed, which moves to VectorWise. And so let me push the button slowly there. So with VectorWise, to understand how VectorWise breaks from the past, we need to understand a bit about hardware technology. And I'm going to go ahead and build this slide out. Give me a second here. All right, so let's talk a little bit about chip technology. And because VectorWise harnesses the investments that chip manufacturers such as AMD and Intel have made on their chips, and which numbers in the billions of dollars. And so there's two concepts that we need to think about when we're looking at chip technology that's relevant to this discussion. And that's sort of the size of the different devices that make up the modern architecture, and then the speed to process data. on the left hand over here in the 1980s, we had a Pentium, which ran, if you remember, about 50 or 60 megahertz. Whereas if I look at today's modern chips on the right-hand side, you're looking at chips that are well above 3 gigahertz in terms of processing speed, and that has a lot of implications. Again, go back to the 80s on the left-hand side. In terms of RAM, you probably were looking at tens of megabytes of RAM. If it was 100 megabytes of RAM, that was a lot of RAM. Go back to the right-hand side. Let me look at that L3 cache in that circle up there. Today's latest chips are coming out with 20 megabytes of RAM per core. All right, so again, 20 megabytes of, not RAM, 20 megabytes of L3 cache per core versus in the 80s, that's how big RAM was. Move down to the disk drives. The disk drives in the 80s, you were lucky if you had gigabytes of disk drives. Move to the modern era, you have gigabytes of RAM, probably tens of gigabytes of RAM. And the only thing that was terabytes in the 80s was tape, and today you have terabytes of disk drive. So everything in this architecture has moved up. And so from that perspective, from a size perspective, that's important to take note. What's even more interesting is the speed. If I go back over to today, the CPUs of the 80s, it took about 1 clock cycle for the CPU to access data in RAM. 1 clock cycle. All right. Today, for that chip on the right-hand side to access data in RAM, it takes hundreds, maybe 200 to 300 clock cycles. So a lot of that processor goes unutilized if the data is sitting in RAM. So the key is what VectorWise does is say, look, we need to optimize for that chip on the right-hand side and be very efficient about moving data into that L3 cache. What I will assert is that many of the databases on the market were designed in the 80s, and they were optimized to an architecture on the left-hand side that was really built around memory and disk drives. So that's the modern architecture that I wanted to walk through there. Let's talk about VectorWise. So we're going to spend a little bit of time on this slide. So the first point on the left-hand side, there's a couple facets to this particular point. We've talked about the hardware architecture, and there's a number of components of VectorWise that allow us to be very efficient and very effective of moving data from disk to RAM to the L3 cache and then optimizing the chip. I'll talk about a number of those components on the right-hand side, but again, I'm going to assert that we're very efficient about that moving data from disk, RAM to L3 cache. Let's spend a little time here talking about point number 2, which is vector processing. So the opposite, or what many of the predominant databases do today, is what we would call scalar processing, which means an element of data at a time is worked on. With VectorWise, we use vector processing, which means that with a single instruction, the chip is operating on an array of data as opposed to a single element at a time. Also, by operating on these vectors, and also by optimizing our code for modern compilers, we're much more efficient in terms of using today's modern chips. And where some of that efficiency comes in is, I'll give you an example, is VectorWise cuts down on a number of what I call, what's known in the industry as branch mispredictions. Today's chips try to predict, they do out of order execution across multiple pipelines, and they try to make some predictions as to what data and what instructions should be operating. Because of the way that we've optimized our code and because we're using vectors instead of elements at a time, we cut down on a lot of the inefficiencies that take place with the predominant databases on the market, which when you look at their code have a number of branches inside of them. So that's a number of the components around the vector processing. So we're using vector processing, vector registers, and vectorized primitives to execute on this. A third point is a column store, which if someone has been in the analytical database market. It's been around for probably 15 years plus. And what that does is allows us to move the data that's going to be analyzed most likely into the RAM and into the chip cache, as opposed to moving rows of data which may have columns or data that's superfluous to the analysis, and again being inefficient. So the column store really helps us move from disk to memory to L3 chip cache. And then the fourth point I would point out is what I call smarter compression. And here's what we mean when we talk about smarter compression: is some products on today on the market will try to maximize compression, and what they're maximizing again is they've optimized for disk storage. And we're of the opinion that disk storage is very cheap, but what is at a scarcity is the chip cache and also the chip processing. So we use multiple compression algorithms depending on the type of data that we're processing, and we optimize for the speed of decompression so that we can move quickly in operating on the data. And then we also have algorithms that make sure that we're not decompressing or moving data around unnecessarily. So again, this is what we call smarter compression. So that's some of the facets of the VectorWise technology. Let me talk about some of the so whats. Why should someone care about those technologies? And it's really some of the proof points that we have around VectorWise, and it comes down to go back to my point about conversational analytics. We need to have a database that is very fast, very responsive. And here is an example of how VectorWise compares to other products on the market. This is the TPC benchmark. This particular one is for 100 gigabytes, and let me just take a minute to explain this. The left-hand axis, or the y-axis here, is a metric that I would equate with miles per hour. It's actually a very precise metric of QPHH. And the bottom axis is benchmarks over time by specific database vendors. And so what you'll see if you were to look at the gray bars there from other companies is that this benchmark advances maybe 10, 15% every year until VectorWise came along. And what you'll see is in early 2011, we published the first benchmark with VectorWise, and we received a score that was almost 4 times the previous best. The details aren't on this chart, but that machine for that benchmark right in the middle, VectorWise 1.5, was nearly identical to the hardware right next to it that was the previous best. What you've seen subsequently is other hardware manufacturers have taken VectorWise and published benchmarks, and we continue to see results that are going up and to the right. And if we did the math there, I think we're looking at oh gosh, well, I can't do the math that quick. So got to be, what is that, 30% increase in about a year. So that shows our performance. And I'm going to move to the next chart to make another point about our affordability here. This is another TPC benchmark. This one's for 1 terabyte. And the point I would make, look at the VectorWise bar there for a second. And if you look at the number, go down in the middle of the bar, we used 32 cores for this particular benchmark test. And you can see we had a score at the bottom was about 436 QPHH, or miles per hour in my terminology. And that's at least twice the best score on that page, or about twice the best score on that page. If you go and look, if you were to look at the number of cores that the other systems are using, best case we have Oracle is using twice as many cores as VectorWise is to do their processing. All right, so we're using less hardware. There's other products that are using 80 cores when we're using 32. The other point to look at is the cost, which is at the very bottom. It was 88 cents per QPHH for VectorWise, and you look at some products that were over $9 and others that were well into $1, maybe twice as much as the VectorWise solution. So what we've shown here is we're delivering superior performance on less hardware, and when we add up the total cost of the solution, which is what the TPC benchmark does, we have a very attractive price point. So that's sort of the benchmarks proof points around VectorWise, and this is really what brings forward that performance that I call conversational analytics. And the next chart I'm making, this is kind of a fairly blunt chart. There's a few analysts that have actually done studies out there as what is the impact of query performance. And a few folks have actually done this, created some indices that show that as the query time increases, the value of the business intelligence solution declines. And so go back to this point that I was making before, is that conversational response time, 5 to 10 seconds or less, is where the greatest value is realized. And really what that does is it allows business users, those end users, to analyze data quickly. It's unaggregated, it's granular, and people can bring the data to the problem, and they can ask questions of the data, and that's why you need granular, unaggregated data. So let's move on. So let's give a couple examples here. I've covered sort of my hypothetical example of myself buying a DVD player. I've listed a few customers here. Sheetz is a leader in quick service restaurants and convenience stores on the East Coast, and they've implemented an executive dashboard on their point of sale information. And when you're talking about an executive dashboard, it better be conversational from the perspective of it needs to be engaging, interactive, and meaningful. And what they were able to do is increase the amount of data that they were able to analyze to billions and billions of rows and get the response time that we're talking about here. On the right-hand side is a customer of ours in Europe, Timocom, who has a software as a service application for freight exchange. They, when the large overnight companies or shippers land an airplane in a large city in Europe, Timocom will address getting the freight from the airport to the local customers. And they've implemented an application on VectorWise for fraud and theft detection. And just speaking conceptually at a high level, what they're doing is when somebody is interacting with their system, it could be a customer who's trying to find out about their shipment, or it could be somebody who's trying to execute a heist on a shipment. And so they need to analyze the behavior of that interaction with some other data that they have and determine, okay, is this a customer that has a problem they're trying to solve, or is this someone that's trying to commit fraud or theft? And you want to make sure that you treat your customers very well and that you're able to prevent theft. And so that was very important to them, and they needed to do that in a real-time basis. So I think two examples of where the performance matters, and we get into this conversational analytics piece. Let me jump forward and explain how we move from conversational analytics to our new initiative, which is action apps. And what we defined action apps as is applications that are lightweight, consumer style, that automate business actions from an analytics perspective. And these came about for a few reasons. There's a few trends that really sort of fuel what we call action apps. And again, it comes back to, at the top point, you have a number of devices and interactions in our personal world that make computing real-time and conversational versus the corporate experience. When you're sitting behind a desk, there's a lot of work that seems like batch processing, and people will multitask the batches. So that's sort of one point. The second is analytics is fine, but action is what fuels success. People need to take action to drive their business forward. And so we've developed this category of action apps, which is really powered by the Cloud Action Platform. And the Cloud Action Platform is a set of technology which includes both the Ingress transactional database as well as the VectorWise analytical database. And it enables people to execute now, in the moment, and take action on analytics as it happens, as opposed to if you were sitting at a dashboard and watching the dashboard all day. So let me give you a tangible example. The best one we use is a sales pipeline. So think of a Salesforce automation application, and if we had a chart, what's happening in the pipeline? And if somebody were to stare at that all day and see the movements when a salesperson made a change in their pipeline, okay, that's great. That wouldn't be very efficient. But that's the only way that you could be actionable without action apps. You know, if you look at what today people do with their sales pipeline analysis, it's probably end of week or end of month when there's a pipeline review and you say, oh, wait a second, this one opportunity fell out of the sales pipeline. And if we had known that when it happened, we could have called the boss in and tried to save that opportunity and move that customer forward, and now it's too late. If they had implemented an action app that had alerted them to take a specific action when the opportunity was starting to go sideways, they would have saved the deal. Or they could even automate other actions from systems. Did you know, let's tie this into our LinkedIn system, and did you know that your lead, your champion at this company that's going to give you expect to give you a purchase order just left the company? So that allows you to take some action in the moment. So this is our new initiative, which is the Cloud Action Platform, which will fuel these action apps. So let me just summarize what we've covered from a VectorWise perspective and conversational analytics. My assertion is that most databases were designed for 1980s hardware. And VectorWise is really making a change with the past and moving forward and leveraging the improvements over the past 30 years in hardware, in processors, cache, compilers, and memory. And what that enables people to do is really solve problems in the moment as opposed to throwing more hardware at the problem or more money at the problem. Instead of throwing the money at the problem, why don't we solve the problem, which is making decisions and moving your business forward with data. We talked about a number of proof points, technical, and some customer stories. And what again I will say is VectorWise, our speed really creates value from data by bringing in the moment, optimizing your business, optimizing your data infrastructure, and allowing you to make your customers happy. So with that, I appreciate the time today. Let me turn it back over to Eric.
All righty, and I'm going to go ahead and make Robin Bloor. Actually, I'll make myself the presenter for just a quick moment here. I've pushed Robin's first slide. There he is. And Robin, I'm going to give you the keys right now. So if you would just click on that slide and use the down arrow on your keyboard.
Okay.
There you go.
Indeed, I seem to have got the technology working. Okay, I would agree with what Fred just said, that a lot of the database technology around was actually designed really for the architectures of the 80s. And therefore, I guess that's a topic that we will probably pursue quite a lot when we get to questions. What I'm really trying to do here is to, kind of riffing off Fred's presentation, is just talk about the nature of speed in IT, because I think it's kind of worth thinking about. One thing that I noticed, and I actually did a presentation sometime in the late 1990s, which was just themed on this. There's nearly always an advantage improving the speed of a business process. And you can kind of, it's kind of conceptually the case, I mean, if airplanes could get you faster to and from New York, you would take the faster airplane given that the price was okay, and so on and so forth. I mean, everybody naturally recognizes that business processes are better if faster. The interesting thing, I think, is that certain business processes get a huge leap when they go past a certain barrier. And other business processes, yes, they're better, but it's not a huge competitive advantage you get. It's just an improvement that everybody's very happy with. So let's talk about big analytics. I mean, in actual fact, I would characterize big data as being mostly about big analytics in the sense that that's where the opportunity is. That's what's happening is people are gathering together vast amounts of data. But it's because they can perform analytics on it. It isn't, or at least mostly, of course Fred comes up with an example to prove me wrong, but it isn't mostly about better dashboards. It's mostly about deep analytics of the data that you're actually after. So the question really is, you know, when you're carrying out analytics, what is the problem of latency? And I think there's two situations here, and I think kind of Fred's already mentioned this, but I'll depict it slightly differently. When your interaction with the data becomes conversational, rather than when your interaction with the data is going through step-by-step analysis that gradually gets you to a point where you realize something. And there's something very different between those situations. So I've seen, you know, data analysis situations, data mining situations, where someone's going through like a half a day or a day to find something out. And if they could have just sat in front of the data and been able to get an answer reasonably quickly, then they could have done their job vastly quicker than the way that they do the job. And that's, I think, what's being talked about here. If you have really fast databases, and it's not just really fast databases, it's well-designed data flow that feed those databases, and you have the right analytical tools, then the possibility arises that you will get analytics in terms of what I've called truly actionable latency. And truly actionable latency is a response that's an imperative in certain situations. For instance, credit card fraud. You have got only seconds to detect whether credit card fraud is in process in order to be able to do something about it. Telco customer churn, that seems to be a very short latency thing. Certainly risk analysis in the financial sector and actually in other areas is also an imperative. So there are some areas where truly actionable latency pays in a big way. And there are other areas where, well, they're still going to do long streams of analysis. And there are also, you know, problems that even with the fastest hardware and the fastest software and the best tools available, you still can't make the latency come down to less than a tenth of a second. And that's, you know, that's, let's say, the edge of progress in the analytics space. So what I'm saying here is that, you know, where the rubber really meets the road is that analytics needs to be a precursor to action. There are actually very few analytical techniques, and most of the techniques that we use now, well understood, well established, some of them established long before we actually even had computers. You know, because most of it has come out of statistics, and that as an area of mathematics has been well understood. There have been some what I would call innovations. Certainly neural networks were innovations. And there have also been new techniques introduced in the analytical space. But even so, it isn't something that, you know, that you can expect to arise, you know, next month or the month after, that someone suddenly found a beautiful algorithm that allows you to see things that you couldn't see before. Most of the analytics is kind of known about. So really the challenge with analytics is whether the analytical activity is well integrated within a business process, so that when a trend changes, a business can respond. And there can be two things here. One is it's a contextual trend, which means it's something that's going on in our business we need to fix or maybe need to take advantage of, and therefore needs to be responded to very quickly. And then there's a situation of quickly enough where it's a general trend, and if you don't respond, your competitors may respond faster. So there's an imperative in competitive terms, and those are different situations. But sometimes businesses perform the analytics and they fail to act, and it's more common than it should be. And a lot of that, some of it has got to do with latencies and some of it has got to do with technology, but in my opinion, a lot of that has got to do with the fact that actually they haven't actually organized their business processes particularly well. So you've got people finding things out, passing information on, and the information is not being acted on or not being acted on in time, and that's a failure of business process rather than a failure of the technology. And it's worth bearing that in mind when you kind of look at this space, because it isn't a one-dimensional space. What I've done here is what Fred didn't do, but what I've done is I've put up a generalized architecture for vector processing, just so that I'm hoping it's kind of clear to everybody what's going on here. The first thing is that, in my understanding, Vectorwise is a column store database. So the stuff that you see on the left half of this diagram is typical of what happens in a column store databases. There are loads of column store databases out there. Well, maybe not loads, but there's certainly quite a lot. And they all work in this way. Take a database table, compress the stuff in terms of data, partition it across disk, use a parallelism of multiple disk channels into memory, and then you parallelize across the CPUs in order to process the workload that you're going to do. The difference with Vectorwise, if I understand it correctly, and I'm sure Fred's going to correct me if I've got this wrong, but if you look on the right-hand side, you know, the advantage of parallelism on disk, well, yes, all of the column stores can get that. And the advantage of parallelism in terms of memory itself, well, the column stores can get that too. Where Vectorwise differs is it's actually doing parallelism at the CPU core, not even, as I would say, on the CPU, but at the CPU core. And because it's doing it at the CPU core, it's just got a level of parallelism that other products don't have. And that's why in these benchmarks, you're going to see Vectorwise outperform other products, because in most circumstances, benchmarks are fairly one-dimensional. And therefore, as long as they tune up the database and power it into a TPCH, you're going to get good results that other vendors can't get. I mean, that's going to happen. The other thing, I suppose, to be fair, is that the price per transaction is very low with Vectorwise, so it's also a nice economic model. You're not being charged a lot of money in order to go fast. So, you know, in the general sense, what I'd say that the challenge is speed, but it's also effectiveness, right? Big analytics is here to stay. There's no, you know, it's like, it's almost at the stage of a wild fashion, you know. I mean, there's a tremendous amount of people doing tremendous amount of things with big heaps of data, partly because there's a lot of new data that people didn't analyze before, but partly because we've got these engines that allow us to do the analytics, and therefore there is genuine business advantage that's being won. So in some analytical application areas, speed is desirable. In others, speed is critical. So, you know, if you've got a dashboard and it's got a 5-minute latency, if that comes down to 2 minutes latency, it's probably not going to make a big difference to the business. But if you actually get analytics, results from analytical activity that allows you to act and gain business advantage, then the speed starts to become critical. Analytic speed depends upon the database engine, but it actually also depends upon the data flow architecture around it. It's worth mentioning that you don't just buy one product and all of a sudden your problems are solved, but of course, if you buy a database engine that doesn't go fast enough, then you've got a very serious issue to deal with. And finally, I think business effectiveness really depends upon integration of the technology with the business process. So there's two halves to this. And in that sense, you can lead a horse to water, but you can't make it drink. So kind of that's my summary of this. I got a lot of questions. I may depart from the script here, but I think there's some things that are just worth asking out of interest. And the one that always comes to mind with me is, you know, Fred, where do you think the sweet spot is for Vectorwise? Where is it that when you talk to people on the customer, you know, when you talk to prospective customers, they really sit up and pay attention? What is the sweet spot?
Yeah, sure. So I guess I give it a few different characteristics. There's high volume, and I would also say high velocity, and sometimes we call it the fire hose of data that's coming at a customer. And it's we're structured data in terms of maybe it's generated from a machine generated data, system data, transactional data are the types of data that we handle in volume and at velocity, and it's in the context of reporting, analytics, be it operational analytics or an OLAP. So those are some of the areas, but it's typically volume and velocity that folks are seeing. Sort of a sweet spot is what I would characterize it as.
Okay. What I want to go into is it's very difficult. I know as you're the vendor, you're always going to try and say positive things about a product, but I've never been wildly impressed by benchmarks because they are essentially one-dimensional. However, it's obvious why vendors do benchmarks because they aren't completely meaningless. However, if I were looking at this product, these would be my first initial questions. Is the first, mixed query workloads when you've got short and long queries, you've got a great deal of concurrency on large volume of data. How does it perform in that? Does your edge is the vector processing. Does the vector processing kind of diminish when you've got a high level of concurrency in terms of the advantage it gives?
Sure. So maybe let me cover a few of these questions here. So first, let's go to the last one. In terms of concurrency, we've actually seen some outstanding results around concurrency. And I look at concurrency, so let's talk about query concurrency, which is typically sort of derived in terms of the number of users that are running queries, and then your ability to process quickly. So the fact that we have that speed and that power, we're able to finish the work very quickly, and so our concurrent query count is very high, and we've seen well over 100 concurrent queries running on a 12-core system, to give you an example. And I agree with your point on benchmark. I understand benchmarks and sort of what happens. I guess I would offer two sort of counters, Robin. I think there's the analogy that we could use of someone running the 100 meters and say, well, you tuned up for that race. Well, this is like VectorWise just ran the 100 meters in 4 seconds. All right, is what we just did. It's just that fast. The second thing that I would offer about benchmarks is, when we're ever engaging with a prospect, we say, look, it's best that we take your data with your queries and show the performance of VectorWise. And I would say in every case, there's one that's out there that we're seeing better performance than what we see in the benchmark results. So let me see if I hit on. And then you talked about heavy-duty analytics, and I think when you look at what so I would define heavy-duty analytics again in terms of volume, and the velocity and the vector processing, and as you pointed out very, very clearly, our ability to parallelize all the way down to the core allows us to just eat up those queries, and that would be characterized as heavy-duty analytics. So I think you described it very clearly in your presentation as to how we're able to apply that.
Yeah, I mean, I have to say, in terms of the benchmarks, I was when I first saw, because of course I came in contact with VectorWise about 18 months ago, and when I saw the level to which you were actually beating the competition, it was obvious to me that this isn't a couple of software engineers that know how to tune their product. This has obviously got a huge advantage. But I would say of your graphs, one of the more interesting things that I don't think you dwelt on very much was actually the improvement of VectorWise over 3 benchmarks, because that itself was significant. That means
it is.
Yeah.
Yes.
I presume that some of that's got to do with the fact that you had further releases of the product in between those benchmarks. Right?
Exactly. No, the product has gotten faster, and our roadmap is going to make it faster as well. And then when we start seeing some of the new Intel chips, I'm expecting results that will be quite strong.
Yeah, I think the chip market works in your favor because basically the chip vendors can do nothing else other than actually add more cores to the chip and in order to make them go faster and faster. I mean, they're kind of trapped into that situation, and therefore, this things like Hadoop, where people are pushing them out onto 300 servers. Well, there isn't going to be 300 servers to do those kinds of workloads in the future because they'll actually be eaten up by 20 or 30, And that's kind of what's happening at the chip level, but it does mean that the chip actually has to be made to be busy all the time, which is, again, it's an advantage you have. You didn't mention anything about ingest. How does Vectorwise deal with ingest?
Quite well. And so actually I'm glad you asked that question. It's a good one. So let me give you an example. It's just a proof of concept that we had in the last 6 months. We had a large financial firm in their European operations that had a requirement to ingest data. I always feel like I'm digesting, but I got to say ingest data at a very high rate. And we were talking, I think it was well over 100,000 records per second. And while at the same time they wanted to achieve this concept of what I call conversational analytics, meaning query response time in less than 5 seconds. So we've proven that with customer data, and there's other aspects of the product that allow us to insert data into Vectorwise while folks are running queries online in hop.
Right. So what you're saying is that ingest it runs entirely concurrently with the query load, and we could be streaming data in, and it would still do that. I know if you stream enough data, you're going to cause problems, but you could be doing that, and that's how it works.
Exactly. No, you're exactly right.
Okay. You talked about the cloud service. The interesting thing to me was that it just kind of the way you presented it, because you're kind of talking about this application capability you've got, which isn't our focus here, but it's almost as if Vectorwise looks just, well, okay, it's a fast database in amongst this cloud service. Is there anything, or is there any way you could speak to how you feel that you would differentiate in terms of being a cloud service like that from other vendors? Because, of course, a lot of vendors are doing that.
Yeah, so I look at, cloud is a fairly broadly used term. And what we have had a number of customers that really suggested and brought us into the cloud, and we've actually formalized that offering with a partner of ours, Rackspace, who's very well known in the hosting market and as an infrastructure provider. And what we've done there is really created a packaged offering so that it's on demand. And the aspects of Vectorwise that lend themselves, and cloud is I say it's an overused term sometimes because cloud is just it's a delivery system. In my opinion, software will end up being everywhere. It'll be in the cloud, in the public cloud that's shared. It'll be in a private cloud. It'll be on premise. It'll be in my car keys. What allows Vectorwise to some of the capabilities that we have that are differentiated here. We make it is our simplicity, the ease of use, and some of that comes very much from the power of the product. We don't require people to have a master's in computer science to write SQL against Vectorwise. It's very common tools can write SQL that, frankly, the SQL that comes out of the tool doesn't look very attractive or very elegant. But because of the power of the engine, we're able to consume it quite well and provide people results. And so I think that would be a key capability that allows us to spread the product far and wide. So that's probably one element that I would bring into that discussion.
Okay, I've actually kind of run out of time, and I'm going to have to hand it back to Eric and let the audience loose on you. Okay.
All right, great.
Okay, good. We got a lot of great questions from the audience here, so let me just start throwing some of the over to you. So here's a general question someone asks. How do existing applications connect to Ingress or VectorWise? I know you talked about ODBC and JDBC. Can you talk about connecting to sort of a variety of applications?
Sure. So yeah, you hit it. It's so the primary connectivity interfaces are ODBC, JDBC, also .NET, and so VectorWise has a very good SQL parser front end that we inherited from the Ingress database, and so standard SQL. We do a very good job on it, whether it's elegant or not so elegant. And so from an application perspective, I would say the dominant BI tools in the market have already certified VectorWise, so we have a very strong ecosystem for folks to get started with.
Okay, good. And someone wants to ask about chips. Do you only work on x86 or do you work on other platforms as well?
So today we have only delivered the product on x86. The architecture lends itself to modern chips, and that would include a number of other chips on the market. We just haven't seen the demand yet to move to those other platforms.
Okay, yeah, fair enough. Here's a good question. What about workload management, and how do you deal with things like mixed workloads?
Sure. So today we do very well with mixed workloads. Again, the power of the product allows for short-running queries to be completed very quickly, and we have some proof points out there with concurrent query use cases from customers that are very high, 50 to 100 concurrent queries running. And we also will introduce some more workload management capability to the product in the next year that allows different classes of workloads or users to be assigned to the database.
Okay, good. And here's another very specific question. How do you compare what you guys are doing with some of these in-memory database technologies out there?
We compare phenomenally well. So think about an in-memory database. If you go back to one of my slides on chips, is that an in-memory database is optimized for memory. And my slides and Robin's points, we've optimized for chip cores, and the vector, we parallelize all the way up to that chip core. And so I would assert that we've brought the data to the computing as opposed to just putting the data in memory is my first point. My second point is that in-memory databases are limited. They're limited to memory. And so when you run out of memory, or even before then, you're limited. So most x86 systems today will be less than a terabyte of data, and even if you have some compression, that's not very much data.
Yeah, right. Okay, good. And let's see. All right, so where is a breaking point? One of the attendees asks, how are you handling very large data sets like those in the terabyte and petabyte range? And can you kind of talk about where there might be an inflection point, like where you might start to see some performance drop off in terms of size?
Sure. So I think there's kind of two. There's a technical answer, and then there's an economic answer. And they're close but different. If you look at the economic answer today in the market, I would say we play extremely well in the 1 terabyte or even below, up to 10 to maybe 20 terabytes. And the reason I make that assertion, if you were to go on the market and try to procure a 5 terabyte system or a 10 terabyte system, the cost of that system will be much higher than the cost of a VectorWise system, fully loaded hardware, software. You're talking maybe five times more expensive. As we get into that 20 terabyte range, maybe it's 10, maybe it's 20, but for sure in the 20 terabyte range, then I think we start to have a closer economic proposal in terms of the cost. And so, and that's kind of where I think the technology as well in today's deployments we start to get matched by what's on the market today. Looking forward, which is always what we do in our industry and technology, I think that we start to move that that number up in the coming quarters, and for sure in the next coming 18 months. So that number starts to get into the 30 to even 50 terabytes here in the next year and a half.
Okay. Okay, good. Here's another good question from one of the attendees who asks, didn't Ingress exist in the 1980s? Was this a complete rewrite?
Yeah. So Ingress in the 80s were cool. I was a teenager and I was cool. So so yes, Ingress existed in the 80s. What we've done is we borrowed the code is we borrowed code from Ingress that has moved us forward, where a startup would have quite a bit of challenges, recreating their own SQL layer, an optimizer, and other management aspects of the database. So we've taken the proven parts of Ingress that we needed for VectorWise, and then we've rewritten the core execution engine that allows for the vector processing, as well as the storage engine. So there's two key pieces that were completely rewritten from a modern architecture.
Okay, good, good. Let's see. And just for my own edification here, the core technology, was it the basic design that was put together by Dr. Stonebreaker way back when?
So on the Ingress side, yes. On the VectorWise side, the technology actually, the genesis of this is actually a research institute that they've been working on columnar databases for on the order of 15 years. And so the genesis of the VectorWise core engine comes from a research institute in Amsterdam, and Ingress comes from Dr. Stonebreaker.
Okay, good. And I threw up this slide about these Actian apps. I think this is very, very interesting stuff. Can you kind of talk about the genesis of where this came from? Because, and let me just give you my understanding, it seems to me what you're doing is you're creating these apps that allow people to customize and alter business processes based upon alerts that they get from, for example, one of their systems using your technology. Can you talk about where this came from and what kinds of things people are doing with it?
Yeah, exactly. So today, we have not released action apps. They'll be coming out later this year.
Okay.
And the genesis of this was our early adopter customers. We spent some time with them to see what they were developing on top of VectorWise. And you described it very clearly, Eric, in terms of bringing the data and the power of VectorWise to the business process. And by providing a level of automation and sort of allowing people to automate the action that would take place is what motivated us here to seize on this opportunity. And so we're investing in this. I think we're a leader in starting to invest in this and bring this to the market. And what it was really kind of came out of the customer interaction, how people were using VectorWise, and the fact that people wanted to, you can't sit there and at the end of the week do the analysis. It has things happen during the week. Business is real time, and you need your systems to be real time. And so that was the genesis of it. And then also and real time has many aspects to it, which leads to executives needing to get questions answered very quickly or know what's going on in their business in a real-time basis. So that was the genesis of it, and it's something that stay tuned, because we'll be making some other announcements later this year.
Yeah, I think that is a really, really interesting direction to go, because what you're doing is you're essentially allowing people and users to tap into the analytics that are happening by these triggers and things and impact business processes in real time. I mean, you hear all this talk about agility and agile BI and the agile organization. It strikes me that what you're doing is giving this touch point to the end users that really allow them to respond immediately to things that are happening, right?
Exactly. I mean, you'll see, contrast it with other aspects that are going on in the business. If you look at reporting, it's typically looking in the rearview mirror. If you look at, there's other types of capabilities of predictive. You're trying to predict the future. And action apps are about making decisions on your business right now.
Right. We got a couple more good questions here, and then we'll wrap it up. So one of the attendees, interesting open question here, does VectorWise work as an enterprise data warehouse or a data mart?
Oh boy. So I try not to spend a lot of my time distinguishing between an EDW, Enterprise Data Warehouse, and Data Mart. Here's, so most of the deployments start as a Data Mart, and as people start adding more data sources and more users, eventually that Data Mart turns into what I will call a data warehouse. We don't try to take on all of the corporate data, all of the time, and so, for all of the users. So we don't fit sort of that archetype type standard of enterprise data warehouses, and I don't think a lot of customers are looking for that. So we have lots of sources, and a number of customers are scaling up their users on VectorWise. So yes, we are a data warehouse, and yes, we are a data mart.
Okay, good. And here's a really good question, too. One of the attendees writes, so VectorWise is tightly coupled with Ingress, but what about Postgres, DB2, MS SQL, MySQL, et cetera? And I know you do have these traditional connectors, but I guess the question is, does it work best when it's tied directly into Ingress as opposed to other database formats?
Right. So today it only works with Ingress, and it's really sort of the difference between Ingress and VectorWise is some code and, frankly, packaging, which comes out as capabilities. One is transactional and the other is analytics. So there's quite a bit of common code between those two products.
I see. Okay. All right. I think that's all the questions we had here. A lot of really good ones, folks. Oh, well, so, okay. One last question, very specific one. Does Ingress support SQL 92 or whichever?
Oh, yes. So we're absolutely on SQL 92 and some of the more recent versions of SQL 99 and some 2003.
Okay, good. Well, folks, we've been talking to Mr. Gallagher here, Fred Gallagher from Actian, formerly Ingress. For those of you who thought, wait, Ingress, was that a different company? No, it's the same company. It's now called Actian. I love the name. We will archive this at InsideAnalysis.com, folks. You can come back anytime. Usually takes about a day to get that up and running. But very big thank you to our friends from Actian and also to our own Robin Bloor for his insights. We really appreciate that. And like I say, once the archive is up, please feel free to pass this on to your colleagues and friends. And if you feel any question you asked was not answered, you can just let me know, and I'll be sure to get it through to the appropriate person. So this does wrap up our broadcast for today. We'll catch up to you next week with composite software. Until then, folks,